In this video, I want to solve this linear first order non-homogeneous differential equation y prime of t minus 3y of t equals t with y of 0 equals 0 initial condition. I want to solve it in as many methods as possible. So the first method that I want to use is I want to solve this as a linear differential equation. So method 1, I'm going to use the linear differential equation method. So what did we do when we had an equation of this form? Y prime of t minus 3y of t equals t. Well, we actually looked for the function p of t, which is actually the function that we multiply by y of t. I should mention that t is the independent variable and y is the dependent variable. So p of t is the function or the coefficient that is multiplied by y of t on the left hand side. So we are going to multiply by e to integral of negative 3 dt by this integrating factor, so that the left hand side becomes a perfect derivative. So e to negative 3t is going to be multiplied in this equation. So we get e to negative 3t y prime minus 3e to negative 3t y equals e to negative 3t times t. So the left hand side, it's actually the derivative with respect to t of e to negative 3t times y. Let's double check. This is product rule. So if we differentiate the product, if we differentiate this one first and we keep this one, we get the first term. And then plus, when we differentiate this function, we get negative 3e to negative 3t, and then we copy the yellow on the y. So actually, yeah, we got exactly a perfect derivative and equals to e to negative 3t times t. So then we integrate both sides, the equation. So we get e to negative 3t times y equals integral of e to negative 3t times t dt. So e to negative 3t times y equals, and I would advise you to pause this video and solve the integral from the right side by integration by parts. So I solved it. I chose as my u to be t and my dv to be e to negative 3t dt, and then du would be dt and v would be the integral of the above equation. So we end up with e to negative 3t over negative 3t minus e to negative 3t over negative 3 dt. So e to negative 3t times y is negative 1 over 3 e to negative 3t times t plus 1 over 3, and then integral of e to negative 3t dt, it's e to negative 3t over negative 3. So if we divide everything by e to negative 3t to get the y, we get y of t equals negative 1 over 3t and then minus 1 over 9. And I should also mention that when we calculate an indefinite integral, we get a constant. So very important to not forget the constant, which I almost did, because here we also get the c times e to 3t, right? Because it would be divided by e to negative 3t, so I can move it at the numerator. So it's very important to not forget it, because this is an important term, right? It's based on c, you're going to get some value there. So you don't want the exponential term to disappear. But we had an initial value problem. Y of 0 was equal to be 0. So then we get here negative 1 over 9 plus c equals 0, which means c is 1 over 9. So the final answer using y of t would be equal to negative 1 over 3t minus 1 over 9 plus 1 over 9 e to 3t. So this is the solution to the linear non-homogeneous differential equation. And this is just method 1. So I'm curious now what we're going to get with different methods. So let's try undetermined coefficients method. So again, y prime minus 3y equals t, y of 0 equals 0. So undetermined coefficients means I want to have my solution as the sum of a homogeneous solution, right? The solution to the homogeneous equation plus the particular solution. So let's calculate the homogeneous solution first, which means I want to solve this equation y prime minus 3y equals 0. So one way we can solve it is finding the auxiliary equation, which is r minus 3 equals 0. So r equals 3. So we learned in the past that y of t is going to be a constant times e to 3t. Now the particular solution is of the equation, well, because our right-hand side is equal to t, we are expecting the particular solution to be of the form at plus b, a linear equation, or yes, a linear function. Yp prime of t is going to be a, so we replace them in star, right? Well, let's call this star, and we get a minus 3at minus 3b equals t. So on the right hand side we have a linear function, on the right hand side we have a linear function. So negative 3a equals 1, right? The coefficient of t from the left hand side equals the coefficient of t from the right hand side, and the constant a minus 3b is equal to the constant on this side, which is actually 0. So this is a system of equations. A equals negative 1/3 and 3b equals a, which means b equals a over 3 or negative 1 over 9. So having this information, y of t is going to be the particular, general solution, which we see it's c times e to 3t, right? This is the homogeneous solution. And then plus negative 1 over 3t minus 1 over 9, which is the particular solution. So in order for us to find c, we use the initial condition y of 0 equals 0, which means c minus 1 over 9 equals 0, c equals 1, 9. So y of t is equal to 1 over 9 e to 3t minus 1 over 3t minus 1 over 9. So we got this solution using the undetermined coefficients. And let me double check, do we get the same thing? So this solution with the first method is the same solution with this method. Yes, it is. Very good. But let's discuss this situation. How else would you solve y prime minus 3y equals 0 instead of writing auxiliary equation? What other option you would have had? Well, what we can do is we write dy dx equals 3y, and then we use separation of variables. So we can multiply by dx, and we had the conversation of it just works that we can multiply by dx. Normally, we should not separate dy dx, but it's a shorthand operation that in this case it just works. So if we divide by y, we get dy over y equals 3dx. There is also a rigorous method to do this instead of separating the variables like that, and it's still the separation of variable method, but we'll use this one So now the left hand side it's ln of absolute value of y, the right hand side is just 3x plus a constant. So if we raise everything e to everything, we get absolute value of y equals e to 3x plus c, absolute value of y equals e to 3x times e to c, which is a constant, right? So I'm going to write it again, c e to 3x, or absolute value of y can be written y equals plus minus c e to 3x, so y is equal to c e to 3x. And we got the same thing, but I think doing the auxiliary equation, it's much faster. Now let's do the same problem using Annihilator method. So y prime minus 3y equals t. Now in Annihilator method, we have to think what operations are, or what is annihilating t? What do we apply to t to make it 0? So if we do the derivative of a t with respect to t, we get 1. D2 applied to t, the second derivative, is 0. So the annihilator of t is d squared, the second derivative of t with respect to t. Now the left hand side can be written d minus 3 applied to y equals t. If we apply d squared to both sides, we get d squared times d minus 3 applied to y equals 0. So because we have 0, we can separate it into d squared applied to y equals 0 and d minus 3 applied to y equals 0. Now what does d squared applied to y equals 0? It means y double prime equals 0, which we can write in as a auxiliary equation, r squared equals 0 or r equals 0 double solution. So what does it mean that we have a double solution? It means y of t is going to be c1 plus c2x, just because r equals 0, so the term e to rx is actually e to 0, which is 1. Now d minus 3 applied to y equals 0 means y prime minus 3y equals 0, which means r minus 3 equals 0, so r equals 3. It's a simple solution, so plus c3 e to 3 t. Sorry, here I should have written t because our independent variable is t. So having this, and because we've done before the homogeneous equation several times, we know that this is the solution of the homogeneous equation. Solution of homogeneous equation. So basically it's YH, and this one would be the particular solution. And we solve them, so we already know C1, C2, and C3, so I'm not going to do them again. But I want to remind you that when you get the annihilator, then to find, so note, if you had to do this problem just using annihilator by itself, to find C1 and C2, you had to replace just the particular solution into star, into your original problem, and then to find, and of course equate your coefficients to find C1 and C2, and to find C3, replace the initial condition y of 0 into y of 0 equals 0 into y of t once you already found C1 and C2, and you will get the C3. So the order is important because you want to find C1 and C2 first. So we'll stop here with this problem. I will make another video, part 2 of this video, where I will talk about Laplace transform and power series for the same problem.